Hi, my name is Emeralda Sesari. I am from the Department of Computer Science at University College London. Today, I'd like to present my work titled An Empirical Study on the Fairness of Pre-trained Word Embeddings. A field that we're all familiar with, natural language processing or NLP, is a field of study that focuses on teaching computers how to process and analyze huge amounts of natural language data. Word embeddings, which is part of NLP, represent words using real numbered factors to encode the meaning of words. And so semantically related words have factors that are close, such as queen to woman as well as man to king. Since word embedding has this kind of power of showing the relationship between words, analogies such as these three right here contain a worrisome biases that are present in society and hence embedded in word embeddings. There are many studies proposing bias metrics and comparing them, and one of them is word embedding association test, or WEAT, one of the earliest bias metrics ever proposed. It determines the degree of association between lists of words. The authors found that African American name showed higher cosine similarity with unpleasant words. On the contrary, European American names had a higher cosine similarity with pleasant terms. And moving back to word embeddings, constructing a large scale data set is expensive, which is huge barrier for most of NLP applications. So many researchers use pre-trained word embedding models, which have been previously trained on a large corpus because they're versatile enough for NLP tasks. However, many researchers use pre-trained word embeddings without performing an in-depth study, and instead they utilize default settings that come with ready-made word embedding toolkits. But in reality, these pre-trained models are susceptible to inherit stereotype social biases such as ethnicity bias, gender bias, and religion bias from the text corpus they've been trained on. And moreover, it is found that changes in parameters such as corpus size and factorial length are responsible for the majority of differences between word embedding models. However, the impact of parameters of word embeddings on its fairness still remains unanswered. Hence, our first research question is, how do pre-trained word embeddings perform with respect to multiple fairness measure? Here, we carried out a series of experiments. We used the most commonly used bias metrics in the field to assess the fairness of the most popular pre-trained embeddings. Two, how does the factor affect word embedding fairness? And to investigate the effect, factor length was taken into account when we analyzed bias scores produced from the first research question. This experiment was limited to pre-trained embeddings generated from the same corpus under different factor length. And how did we know the most commonly used pre-trained word embeddings and bias metrics in the field? We did what we called a paper selection using these three steps: preliminary search, repository search, and snowballing. In total, we gathered 37 relevant publications. We perform experiments using publicly available pre-trained word embeddings provided by the three most used embedding models: Glove, Word2Vec, and FastText. 10 pre-trained word embeddings from Glove, 1 from Word2Vec, and 4 from FastText. We evaluated the fairness of pre-trained word embeddings by focusing on 4 most frequently used and publicly available bias metrics. They are WEAT, SAM bias, direct bias, and ECT. These two tables report the bias score obtained from the experiment together with the pre-trained embeddings and the bias metrics. We can see here that WEAT test suggests that FastText is the is the least biased model for 5, 1, 2, 3, 4, 5 out of the 7 we test. Next, according to SAM bias, most word pairs in fast text are less biased. And according to direct bias, Glove model trained on wiki gigaword with 300 factor length is found to be the least biased. Lastly, a fast text model that has been trained on common crawl with factor length 300 was found to be the least biased using ECT. And overall, fast text pre-trained word embedding performed the best with respect to 3 of the 4 most used bias metrics. The second research question investigates the effect of factor length on fairness of pre-trained word embedding models. We found that 8 from 14 WITS findings imply that the greater the Glove Twitter and Glove Wiki factor length, the less biased they are. And turning now to the analysis on SAM bias scores, it's apparent that from these two figures that the fairness of the two pre-trained word embedding improves with the increase in the factor length. Next, this figure shows a decrease in ECT score as factor length increases in Glove Twitter only within factor lengths of 25, 50, and 100. 25, 50, and 100. However, between 100 and 200, the bias score slightly increases. In Glove Wiki Gigaword, the bias increases from lower factor length 50 to 100, but rapidly declines beyond factor length 100. And lastly, following the increase of factor length in Glove Twitter, we observe a decrease in the bias score of direct bias. In the next figure, bias score of Glove Wiki Gigaword increases from lower factor 50 to 100, but declines beyond the factor length of 100. Overall, most of our observations indicate evidence for improved fairness in pre-trained word embeddings when the number of factor length is increased. This result implies that lower factor length in word embeddings are not expressive enough to capture all word associations and analogies, and that when bias metric is applied to them, they become more biased than embeddings with a larger factor length. Finally, with in-depth investigation of fairness, we hope that this research will lead to a more directed and fairness-aware usage of pre-trained word embeddings for their application with regards to intrinsic biases. And to this end, we found that the most fair of the 3 pre-trained word embedding models evaluated is fast text. And we also found that while using pre-trained embeddings, the influence of factor length on fairness must be carefully considered. We strongly encourage the audience to read our paper for more detailed information and to get in touch with us for any questions or comments on this work. Thank you.